We're going to talk today about an arithmetic sequence. When we did scatter plots, we looked for patterns or correlations. We're going to take that and extend it just a little bit and talk about a sequence of numbers. Today we're looking for what's called an arithmetic sequence. Here's an example. During a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. When you list the times and the distances in order, each list forms a sequence. A sequence is a list of numbers that often forms a pattern. Each number in a sequence is called a term. Here's an example. Okay, so after 1 second, the distance was 0.2 miles. 2 seconds, 0.4 miles. 3 seconds, 0.6, etc. Okay, you can see that there is a pattern. With the time, it is 1, 1, 1, 1, 1. Look at the distance here. Okay, to go from 0.2 to 0.4, we add 0.2. To go from 0.4 to 0.6, we add 0.2, 0.2, 0.2, 0.2, 0.2. That difference there is called our common difference. This is an arithmetic sequence because it has a common difference. That common difference can be added or it can be subtracted. So this would be an arithmetic sequence with a common difference. We use the lowercase d to represent that of 0.2. We often, like when we're talking about a sequence, we'll use a variable, and we use the variable a to represent a term in a sequence. And then we put a little number down here. So the first term in a sequence would be 1, a1, and then we have a sub 2. I meant to put a 2 there. A sub 2. And the next one's a sub 3. It tells you here that a sub 9 is the 9th term in the sequence. And then to designate any term in there, we can just use a sub n. That's the nth term. Okay? Now you can get from one term to another, like if you want to find, let's say, the 5th term in a sequence. Okay? What you're going to do is you're going to find the one right before that, which in this case would be a sub 4, the 4th term, and you're going to add the common difference. Now, this is just kind of common sense at some point. If you know the previous term, you just add the common difference. Okay? So, for instance, if I have a sequence of 5, 10, 15, and I want the next 3 numbers in line, I need to know, so if I want the 4th term, I need to know what the 3rd term was, and I need to know that the common difference is plus 5. So I add 5 here and get a 20. Now I need to know this term to add 5 to get a 25 and then a 30. That's how easy that is. Okay? Here I'm asking you to tell me if it appears to be an arithmetic sequence. So to go from 9 to 13, we add 4. 13 to 17, we add 4. 17 to 24, 21, we add 4. I can't speak tonight. Okay? The 3 little dots that you saw at the end here just simply mean and so on, like, and that same pattern continues. All right? This one, take a look at this. Ready? From 10 to 8 is minus 2. From 8 to 5 is minus 3. From 5 to 1 is minus 4. This one is not an arithmetic sequence because this is not a common difference. These have to all be the same. Now, if you want to find the nth term in an arithmetic sequence, so 100th term, if I know what the difference is, if I know that what the difference is, I could sit there and I could just add it over and over and over and over again until I got to the 100th term. But that would be craziness. So what we need to do is we're going to come up with a rule for this. All right? So if you start with the first term, from 3 to 5 is plus 2. From 5 to 7 is plus 2. From 7 to 9 is plus 2. So for the nth term, I'm going to add 2 every time. Okay? I'm going to add 2. I need to know, where did this whole thing start? Well, that is a sub 1. This pattern started, and that will be my first term in the sequence. This pattern started with a 3. Now, let's say that I wanted the 80th term. That means I'm going to have to add 2 how many times? Well, our natural inclination is to say 80 times, but that's not right, because here's my first term sitting right there, and I didn't have to add 80 to get to that. I started with that. So this, right, the number of times that you add this right here is going to be 1 less than the term that you want. So I'm going to have to add the 2 79 times. Okay, so we actually have like a little pattern for that. So I'm going to show you here. Ready? So the first term is 3. We added 2 one time to get the second term. So the second term, we added it 1 time. To get to the third term, we added the 2 times. To get to the fourth term, we added it 3 times. That means that to get to the nth term, we're going to add that 2 n minus 1 times. It all starts with the same number. This is the formula for that. So a sub n, if you want to find any term in arithmetic sequence, you start with the beginning term, the very first term in the sequence. You're going to add whatever the common difference is 1 less time than the term you're looking for. You need to know this. Okay? So let's try it. Ready? You don't have to memorize the formula, just know the concept. We need to start with the very first term, which is a sub 1, which in this case is 4.2. They tell me that the common difference is 1.4, so I'm going to add 1.4 over and over and over again, and I want the 12th term. That means I'm going to have to add that 1.4 11 times. Let's take a look at this work. Okay? So again, there's my formula. I substitute in the 4.2 here, the 1.4 here, and since I want the 12th term, 12 minus 1 is 11. Work it out. The 12th term is 19.6. And that's it.